Welcome to Everything Explained. I'm your host, and today we chase a surprising link between two far-flung places, the Sahara Desert and the Amazon rainforest. The question is simple, but the answer is remarkable. How does dust carried by the wind fertilize the heart of the Amazon? The short version is this: nutrient-rich Saharan dust rides across the Atlantic, delivering phosphorus, iron, and other minerals that help the rainforest grow. But to really understand it, we'll unpack how dust travels, what nutrients it carries, how those nutrients affect soils and plants, and what the science currently says. Every year, winds lift huge amounts of mineral dust from the Sahara, from dunes and exposed rock. These dust plumes spread across the Atlantic, pushed by trade winds and weather systems. Some dust settles in the Caribbean and northern South America, some continues all the way to the Amazon basin. The deposition happens in two ways: dry deposition when particles simply fall out of the sky, and wet deposition when rain dissolves and carries the minerals down to the forest floor. It's a slow drip of nutrients, but it adds up over years to something meaningful for the forest soil. Two nutrients in particular stand out for the Amazon: phosphorus and iron. Amazonian soils are often acidic and weathered, and phosphorus tends to be the limiting nutrient for tree growth. Phosphorus from Saharan dust is relatively soluble when it meets rain, so it becomes available to roots and microbes. Iron, a trace element, helps microbial processes that release other nutrients from minerals. Together with calcium, potassium and other trace elements, the dust acts like a natural fertilizer carried across thousands of miles. It doesn't replace rainfall or soil formation, but it eases the nutrient bottleneck that many Amazon soils face. Scientists gather evidence in several ways. They measure how much Saharan dust arrives at the Amazon with ground collectors and satellite data, then compare its chemical fingerprint to dust from the Sahara. They look at leaf and soil chemistry before and after dust events to see if phosphorus and other nutrients rise. Some field experiments have even added Saharan dust in controlled plots to test whether plants respond with increased growth or nutrient uptake. The upshot is that dust delivery does enhance the pool of available nutrients, and in some parts of the Amazon it seems to boost microbial activity and plant nutrition. But it's not a magic cure. Forest productivity still depends on rainfall, temperature, and the broader nutrient cycle. And the deposition is patchy. Some forest patches get more dust than others, so the effect is uneven. Seasonal pulses show up in measurements. When Saharan dust reaches the forest, scientists often find a bump in leaf phosphorus content and in soil minerals. In some long-term plots, growth rates and photosynthetic activity rise after a dust event, especially in nutrient-poor patches. This isn't a fireworks moment, it's a subtle shift that can last days to weeks. Researchers tie these pulses to satellite signals of slight greening and to field measurements of increased microbial activity in the topsoil. The result is a cleaner story. Dust that brings real, detectable inputs helps the forest keep moving even when rainfall fails to deliver extra nutrients. Looking ahead, climate change could shift dust production in the Sahara and the Atlantic wind patterns. If the desert gets hotter and drier, dust emissions could rise, sending more nutrients toward the Amazon. If rainfall patterns change, the way dust is dissolved and deposited will change too. Deforestation in the Amazon itself also matters, because removing trees changes how much nutrients cycle is kept within the forest. So this Sahara to Amazon link sits inside a larger climate nutrient feedback loop. Wind and dust transport nutrients, forests use them, and that uptake affects how much carbon the Amazon stores. Bottom line, the Amazon does not stand alone. Its soils and trees are fed by a global web of flows, and Saharan dust is one of the most striking examples. The desert's tiny grains are carrying phosphorus, iron, and other minerals across thousands of miles, nudging the rainforest toward a healthier, more productive state. It's a reminder that our world is connected in surprising ways, and that sometimes the most distant places are the ones that matter most to each of us. Thanks for listening to Everything Explained. Stay curious.